In part 2 of our series, where we started learning how to convert between mass and the number of molecules, we'll continue answering where we left off, which is question 2. The question reads, find the number of ibuprofen molecules in a tablet containing 200.0 milligrams of ibuprofen. Ibuprofen has the molecular formula C13 H18 and O2. Let's start by finding the formula mass of this compound. And that's not hard to do. We just take the molar mass of each of these atoms, each individual atom's molar mass, and multiply it by the number of atoms contained in one molecule. So the molar mass of carbon, which is found in the periodic table as 12.01 AMU, or grams per mole, we take this and multiply it by 13. Similarly, the molar mass of hydrogen is 1.008 AMU, and we multiply that by 18, and we take 16.00 grams per mole, or AMU, of oxygen and multiply that by 2. Let's go ahead and use our calculator to find the answers to each of these. 12.01 times 13, that's 156.13. 1.008 times 18, and finally 16.00 times 2. 32 plus 18.144 plus 156.13. We end up with 206.274. So all of these added up give us 206.274 AMU. Let's go back to our calculation. Notice that this number had 3 numbers after the decimal place. This number should have had 2, but it's not shown in this calculator. And our first calculation also had 3. So when it comes to adding numbers, which is what we did over here, our final answer has to have the same amount of decimal places as the one with the lowest. And because the lowest amount of numbers after the decimal place was 2, then our final answer should be rounded to 2 numbers after this decimal. So this 4 is insignificant, although we'll continue to use it in our calculation to prevent any sort of rounding error. Our formula mass is 206.274 grams per mole. What I'll do next is take the mass of one tablet, which is exactly what we did in question 1, and it's in milligrams here, so we have 200.0 milligrams, and convert it into grams. The conversion ratio for grams to milligrams is not hard. In fact, we have 1 gram per every 1,000 milligrams. So taking 200.0 milligrams and multiplying it by 1 gram over 1,000 milligrams gets us, and notice that this milligram unit and this milligram unit cancel out, we end up with 0.2000, where all 4 of these numbers are significant. Now taking this mass and multiplying it by what we found earlier for our molar mass, which I'll highlight, we should end up with the number of moles. But how do I do that? I mean, if I multiply 0.2000 by this number as it is, I'll end up with grams squared. Instead, what you have to do is flip this number, where you have grams at the bottom and moles at the top. And you can do that. So I'll multiply this by 1 mole, which is currently there, 1 mole, over 206.274 grams. Now the gram unit cancels out with the gram unit, leaving us only with moles. And from here, I can use Avogadro's number to find out the number of molecules. So multiplying this now by 6.022 times 10 to the power of 23 molecules per every mole, we can get our answer. Let's go ahead and do that. 0.2000 times 1, we don't need to bother with that, times 6.022 times 10 to the power of 23. That takes care of the numerators of this expression, everything at the top. Now we divide this by everything that is at the bottom. And the only thing that's really at the bottom is 206.274. So dividing now this number by 206.274 gives us 5.838 times 10 to the power of 20. Let's write that down. And this mole unit cancels out with this mole unit, leaving us with the units, molecules. Only this thing right here. Now let's make sure that we have the correct number of significant figures. Here we started with 4. We had 4 significant figures here. The amount of significant figures here don't count because that is perceived as an exact number. And the amount of significant figures that we had here was 5. So our final answer should have 4 when it comes to multiplying and dividing. And if you take a look, the number after this 4th significant figure was an 8, so our number should actually have 9 at the very end. 5.839 times 10 to the power of 20 molecules. And there you have it. That is how to answer question number 2. If you want the answer to question number 3, make sure to watch part 3 of this video. We'll see you soon.